Welcome to the Deep Dive, where we extract the crucial insights from key sources, making complex ideas clear and accessible. Today, we're doing a deep dive into just one source, but it's a big one. It fundamentally reshaped how we think about resources and conservation. It's H. Scott Gordon's 1954 paper, The Economic Theory of a Common Property Resource, the fishery.
Yeah, published in the Journal of Political Economy. And you really can't talk about resource economics without bumping into this one. It's foundational.
Absolutely. And our mission here is simple. We want to give you the essence of this paper. We'll break down its main arguments, how Gordon approached the problem, and the really quite striking conclusions he reached. By the end of this, you'll understand why shared resources often face economic ruin and why the answers required a whole new way of looking at things.
It's almost hard to imagine now, but before Gordon, if you wanted to manage a fishery, you'd talk to a marine biologist. It was all about the fish stocks, the biology.
Saving the species.
Exactly. Conservation meant biological conservation. Gordon came along and basically said, wait a minute, that's only half the picture, maybe less than half. He tackled this problem that seems obvious in hindsight. Why do shared resources get overused? But he was the first to really build a rigorous economic model, showing how competition, the very engine of market economies, kind of backfires spectacularly with common resources like the ocean.
And he wasn't shy about it. He points directly at earlier efforts, even by respected biologists like Baronoff, I think.
Yes, Baronoff and others.
And Gordon says, look, their work was flawed, not because the fish biology was wrong, but because they completely missed the human element, the economics driving the fishermen.
He put it quite plainly. They focused on the ecology of life in the sea, but not on man's use of these resources for his own economic purposes.
That really is the crux, isn't it? If you want to manage something for human benefit, you have to understand human motivation.
Precisely. Economics drives behavior. You can have the healthiest fish stock in the world, biologically speaking, but if the economic incentives push fishermen towards behaviors that waste money and effort, well, the resource isn't actually providing much value to society.
Okay, so let's start there. The fishery itself. Why was the ocean the perfect laboratory for this idea?
Well, the fishery is sort of the classic example of a common property resource. Think about it.
Yeah.
Unlike land, you can't easily fence off a piece of the ocean.
No property deeds for tuna schools?
Right. Historically, there's no private title to the fish or the water they swim in. Any fisherman basically can go out and fish wherever they want, within the general rules of the sea. It's open access.
And Gordon saw that this lack of ownership, this common property nature, was where standard economics kind of fell short. It was left to the biologists.
Yeah, economists hadn't really applied their tools specifically to this problem, but Gordon realized this has a massive consequence. The fish themselves, the total population out there, that's essentially capital. It's like a factory or a herd of cattle.
Okay, I see. So fishing is like using that capital.
Exactly. But unlike a farmer who owns the cattle and manages the herd for long-term profit, maybe holding back breeding stock, in the fishery, nobody owns the herd.
So everyone just tries to grab what they can now.
That's the incentive. Why leave a fish for tomorrow if someone else might catch it today? That immediate individual incentive drives the whole system.
Which brings us to Gordon's model. He needed a way to actually quantify this uncontrolled competition. How did he set that up?
He used basic economic tools, essentially modeling the fishery as a production process. He defined three key things.
Okay.
First, fishing effort, which he calls E. Think of this as the intensity of fishing, how many boats, how big they are, how many days they spend out there.
Right, the input.
Then, total cost, C. You generally assume this cost goes up directly with effort. More boats, more days, more fuel, higher cost. A fairly straightforward linear relationship in his basic model.
Makes sense.
And finally, total landings or total revenue, L. This is the amount of fish caught times the price you get for them. And importantly, this revenue depends on both the effort and the size of the fish population itself. More effort might mean more fish, up to a point, but if the stock is shrinking, your catch per boat might go down.
Okay, so we have effort, cost, and revenue. E, C, and L. How did Gordon use these to analyze what should happen versus what does happen?
This is where he contrasts different goals. First, you've got the traditional biologist's goal, the biological optimum.
And some sustainable yield, right? MSY.
Exactly,
Yeah.
MSY. It's the highest amount of fish you can take out year after year without causing the population to collapse long term. From a purely biological conservation view, that's the target.
But as you said, that ignores the cost. You might spend a fortune to catch those last few fish to hit MSY.
Precisely. It could be incredibly inefficient. So Gordon contrasts this with the economic optimum. This is sometimes called the maximum economic yield, or MEY.
And what defines that?
MEY is the level of fishing effort that gives you the biggest possible difference between the total revenue, L, and the total cost, C. Maximize L minus C.
So maximizing the profit.
Yes, the overall profit generated by the fishery for society. Gordon called this the monopoly solution because it's what a single rational owner controlling the whole fishery would aim for. They'd want the biggest net return, not just the biggest physical catch. This net return is the economic rent.
Okay, so we have the biological goal, most fish, and the
Yeah.
economic goal, most profit or rent. Now, what actually happens in the real world, according to Gordon, when it's a free-for-all, the common property situation?
This is the core finding, and it's maybe not what you'd instinctively expect. He showed that free, uncontrolled competition doesn't settle somewhere nicely between the biological and economic optimums.
No.
No. It leads to a situation, an equilibrium, where the average fisherman is just breaking even. Their average revenue just covers their average cost.
Wait, so no profit overall?
Essentially, yes. The potential economic rent that maximum profit society could get, it gets completely wiped out. He called it the dissipation of economic rent.
Okay, hang on. Why? Why does it end up there? If there's money to be made initially, why don't people stop before the profit disappears?
Think about it from the individual fisherman's perspective. As long as they can go out and catch enough fish to cover their boat costs, their fuel, the time, and maybe make slightly more than they could doing something else ashore,
They'll keep fishing.
they'll keep fishing, or new people will enter the fishery. They're not looking at the total profitability of the entire fishery. They're just asking, can I make a go of it?
It's like that gold rush analogy you sometimes hear. People rush in as long as there's a chance of striking it rich, even if the average payout keeps falling.
That's a great analogy. More and more people come in, increasing the total effort. E. This might deplete the stock, making it harder for everyone to catch fish. Costs might go up. Eventually, you reach a point where the next person thinking about entering, or the least efficient boat already there, can barely cover their costs.
So the marginal fisherman is making zero economic profit.
Exactly. And at that point, the total revenue generated by the entire fishery pretty much equals the total cost of deploying all those boats and all that effort. The rent is gone, dissipated, wasted in excessive fishing effort.
Wow. So what does that actually mean for the fishermen themselves? Are they all just scraping by?
Well, yeah, on average. The theory suggests that in this equilibrium, the returns to labor and capital in the fishery will be driven down to the bare minimum they could earn in other comparable parts of the economy, often low skill, maybe even hazardous jobs.
So it's not just that the resource is inefficiently used, the people are too.
It's a massive misallocation. Society is pouring too much capital, boats, gear, fuel, time into chasing too few fish, relatively speaking. The fishery might be biologically sustainable, perhaps, but it's generating almost no net wealth. Fishermen might be working incredibly hard just to make a basic living.
And what about the fish stock itself in this scenario, compared to the biological or economic optimums?
That's the other kicker. This common property free-for-all equilibrium, where the rent is zero. It almost always occurs at a level of fishing effort that's higher than both the level needed for MSY, the biological optimum, and the level needed for MEY, the economic optimum.
So you end up with more boats, more effort.
Catching fewer fish overall than you could sustainably, and certainly making far less profit,
Yeah.
while potentially pushing the fish stock down to levels lower than either the biologists or the economists would want. It's physical overexploitation and economic overexploitation, driven by rational individual behavior in an irrational system.
This is a really powerful idea, and you mentioned it's not just fish.
No, not at all. Gordon himself pointed this out. Think about the historical tragedy of the commons, shared grazing land where everyone puts on too many animals until the pasture is ruined. Same logic.
Or you mentioned oil earlier.
Right. Early oil extraction in places like Texas, before regulation. If you owned land over an oil pool, you drilled. Your neighbor drilled. Everyone pumped like crazy to get the oil before someone else did.
Leading to huge waste, collapsing reservoir pressure.
And ultimately, the need for state intervention like prorationing to stop the chaos. It was the same dynamic. Common pool resource, individual incentive leading to collective waste, rent dissipation, just with black gold instead of fish.
Gordon also looked at actual fishery management examples that were happening around his time, didn't he, to see if they were solving this?
Yes, he critiqued some prominent cases. The Pacific halibut fishery was a big one. It was managed jointly by the U.S. and Canada starting in the 1930s. They used quotas, total catch limits, and closed seasons.
And biologically, it worked, right? The halibut stock recovered.
It did. A biological success story, in a way. But Gordon pointed out the economic side was still a mess. Why? Because they managed the catch, but not the effort or the number of boats.
Ah, so when the stock recovered and fishing became profitable again.
More boats poured in.
Ah,
You had this intense race to catch the quota before the season slam shot. Fishermen invested in bigger, faster boats, better gear, just to get a bigger slice of the pie in a shorter time.
that sounds expensive.
Hugely expensive. The fishing season, which used to be months long, shrank dramatically. Gordon cites it being down to just 26 days by 1952 for some areas. Think about that massive investments in boats and gear sitting idle most of the year.
So the rent was still being dissipated, just in a different way, through overcapitalization.
Exactly. The cost ballooned to meet the revenues again. Healthy fish stock, maybe, but the economic benefit was largely squandered in this hyper-competitive derby fishery.
He also mentioned the Canadian Atlantic lobster fishery, I think, managed with closed seasons.
Yeah, and he saw that as basically just limiting effort through time. It might prevent utter collapse, maybe spread the catch out a bit, but it doesn't fundamentally solve the rent dissipation problem.
Mm.
Fishermen still compete intensely during the open season, and their capital is underutilized the rest of the year.
So the key takeaway, really, is that focusing only on the biology, on the fish count, misses the economic driver.
That's the core message for you, the listener. Gordon shifted the whole debate. He showed that unless your management addresses the economic incentives created by the common property situation, you're probably just treating symptoms. Things like short seasons, inefficient gear rules, overcapitalization, these are often symptoms of the underlying disease, which is a dissipation of potential wealth.
Which logically leads to the question, okay, if the free-for-all is bad and just limiting the catch biologically isn't enough, what is the answer, according to the theory? How do you get to that economic optimum, the MEY?
Well, the paper points strongly in one direction: unified control, meaning managing the fishery as if it were owned by a single entity with a long-term view, like a sole private owner, or perhaps a government agency acting like a sole owner, whose goal is to maximize that net economic return, the rent, L minus C.
How would that work in practice?
This single controller would need to limit the total fishing effort. They'd restrict the number of boats, the amount of gear, or the time spent fishing, specifically aiming for that point where the gap between total revenue and total cost is biggest.
So restricting entry.
Restricting entry, yes, or restricting the overall capacity. This is where later ideas like individual transferable quotas, ITQs, or maybe specific taxes or license fees come in. They are all mechanisms designed to limit that excessive effort and allow that economic rent to actually be captured instead of being wasted.
So unified control, acting like a single owner, is theoretically the only way to maximize the wealth society gets from the resource. It's about stopping the race. Essentially, yes. By limiting the competition for the resource, you allow value, or rent, to be generated and potentially captured for broader benefit rather than just being frittered away in the scramble.
Okay, that leads us to a really interesting place to wrap up. Here's something for you to think about after this deep dive. If Gordon's conclusion holds that unified control is the theoretical path to maximizing wealth from common resources, what are the real-world barriers? Think about the political fights, the social challenges, the arguments over who gets the right to fish or use the resource that stop societies from implementing that kind of control, especially for vast resources like the open ocean or even things like the atmosphere or shared data online.
And maybe consider how much actual wealth, how much efficiency are we leaving on the table today by sticking with systems that resemble that competitive, rent-dissipating common property model? It's a powerful question that stems directly from Gordon's work over 70 years ago.